GE Aviation has had a very exciting 100-year history, but the fact remains, the future is equally exciting. When you look at the number of demonstration programs we have underway, technology initiatives, investments in the supply chain, acquisitions of new technologies, the aviation portfolio going forward couldn't be more exciting. Let's talk about a few of these areas. For one, let's start with the next generation of helicopter technology. We're involved in a government-sponsored program right now called ITEP, and this is to develop an engine to produce the next generation beyond the T-700 for the U.S. government. And this engine incorporates so many of the unique technologies from additive manufacturing, ceramic matrix composites, high-efficiency compressors. It's going to be one of the best engines we've ever built. That's being led by the Lynn team. Meanwhile, in Cincinnati, we're building an equally exciting new program, a next-generation fighter jet engine called the Adaptive Cycle Engine. This is an engine that can operate like a low-bypass turbofan at subsonic speed, and then operate more like a turbojet with no bypass at supersonic speed, and provide cooling air and other important technologies like that for the program. GE is very involved now in military development programs. If you think about the years 2005 to 2015, there was a tremendous mountain of new NPI program involving the commercial world. Today, we're very involved in developing the next generation aircraft engines for the military through the helicopter program in Lynn and also through this next generation fighter demonstrator program here in Evendale. We are also involved in areas that don't specifically involve the engine. In 2007, GE bought Smiths Aerospace Operations, which put us in the world of avionics, put us in the world of electrical distribution. These are very, very exciting technologies, and these technologies match up very well with our efforts with digital technology. There's a new concept out there called hybrid electric. It's basically exactly as it's saying. It's a hybrid of gas turbine technologies and electrical power. It could be in any number of configurations. And this could be what a next generation airplane could be powered by 25, 30 years from now. And we're very involved in that technology, both at our research center, in our epicenter in Dayton, Ohio, where we also do a tremendous amount of electrical distribution and power generation work for airplanes. So our future goes beyond just the engine. The company also acquired two leading additive manufacturing firms, one in Germany and one in Sweden. And this is part of a new business for GE in the additive manufacturing world, and we know the aviation business will be very much central to that as we develop new engines going forward. We're developing so many things in the services world, because remember, one of our key focuses going forward is to manage these massive installed fleets of engines. And so we're very involved in digital technologies, new component repair technologies, ways to make the engines more predictable, a way to bring value to these customers. When you think about this also, about 70% of every one of our new commercial engines is sold with a long-term service contract. So the company is very involved in how we efficiently manage these fleets and support these airlines. Our service play is as important to the airlines and how we support them in many ways as our actual engines under the wings of their airplanes. So as the industry grows and matures, we are investing in technologies that go beyond the specific gas turbine to do other areas of operations for the airlines. At the same time, we're doing game-changing things within the engine itself. So we're really entering a very dynamic world, a world where the industry has never seen a commercial installed base of engines this large before, at 35,000 engines going well over 40,000 within 10 years. And we've never seen this type of activity in many years in our military world with all the new developments going on. At the same time, we've opened 8 new factories in the United States. We have a complete supply chain now developed around ceramic matrix composites. See, it's one thing to introduce the technology and put it in an engine. It's another to be able to mass produce the technology because the supply chain to do it hasn't existed. So we created a facility in Delaware. We created a facility here in Cincinnati. We have one in Durham, North Carolina, and we just opened a facility in Huntsville, Alabama. So in the world of ceramic matrix composites, we have an entire integrated supply chain to produce this material. So our world is growing in the areas of manufacturing and manufacturing technologies, which are extremely important to manage not only this large base of new engines that are in the backlog, because our industrial backlog, we're talking over $200 billion, and that's services and new engines. Very exciting time to be in this industry, and one with an extremely important and long-term future.